Today we're going to look at 3D printed keys, new elastomeric networks, and of course a new kind of elastomeric kind of design family, if you want to call it that way. So first we're going to jump into, well, 3D printed keys. So there's a man in Houston, and he's been accused of, well, actually a lot of things. This guy's kind of a walking fraud supermarket. So in total, 5 felonies. He's kind of like a seems like kind of like a guy who's into lots of different things, including like a fake lease on a car, fake lease on a house, lots of stuff. And one of the tools he used was a arrow key. Arrow keys are kind of mailbox keys, networks for keys for. Well, in the United States of America, you have like in an apartment building, you could have like 50 keys for the mailbox and or 50 different mailboxes, and then the mailman will have a key to go either on the back of that mailbox or on the side of that mailbox to be able to actually put certain things inside of that mailbox, or indeed collect certain things in that mailbox. It's kind of like a key to that group of mailboxes or a whole bunch of different mailboxes, and it's called an arrow key. And what this man is accused of is a whole bunch of things. And one of these things he's accused of is to copying that key, or at least a friend of his copied these mailbox keys and sold them to him and other people. Now, the guy in question is called Larry Piper, and he is going to get charged for this. Now, we're not entirely sure what yet he's going to be charged with, if this charge will go through, if they're going to really make a point out of this. This is, of course, very noteworthy. And it's also, he's using this as a part of a much more complex crime. So what he did is he used the key to obtain the key to then get like a credit card from someone whose data is social security and other data he already had, and he was going to then use that to get money from that person. So it was like a kind of like a part of a much larger kind of criminal enterprise this guy was doing. It was kind of multi-step kind of thing. So we don't know if this is going to go to trial yet, or what part of this is going to go to trial, but this is very interesting. Now, people for more than 15 years have been 3D printing keys. Essentially, if you get a picture of a key somewhere, you can calculate the right angles and the right size of everything. You can print that key. So most keys, unless it is very, very heavy type of like medieval kind of giant door key, you can 3D print that key. There's certain elements of keys where with an internal ball and those system, very security keys that you can't do, but most keys you can actually 3D print a working copy of. And a lot of us have known this for over 15 years. Indeed, I think it was more than 15 years ago that somebody printed a working handcuff key to the German police handcuffs that all the police in Germany wear or have on them. So, this has been around, and first off, the technology has been around for 30 years. Printing keys from a picture accurately has been around for a number of decades now, and only now is somebody getting arrested for it. So that's good. I think we're seeing a long time for for criminality to percolate from what is possible with the technology. So that's good, but hey, we have to kind of watch this space to see, is this going to be criminalized, some part of 3D printing behavior? Are people going to overreact and say 3D printing this particular item is key, is a crime? We don't know yet. So this is something we have to watch, because it's another yet of set of criminality, and we know that can lead to kind of like hysteria and on the part of lawmakers and things like that. So the next thing is, it's essentially, there's EPFL researchers have done something that is really, really cool. I think what they've done is they've looked at actuation, they've looked at soft robotics, they've looked at these parts that move, and they've concluded that the current generation elastomers are kind of quite limited. So what they've done is made something called DNGs. What they've done is it's like a double network of elastomers. So it's an elastomer inside of an elastomer. And what they can do is both of these networked elastomers, essentially, they can vary the properties of these things independently at a particular location, at a particular degree. And they can do that like the inside network and the outside network. They can change differently at different kind of joints or areas. And that gives them an awful lot of versatility and making kind of an actuator type of a thing. They think that you can make joints or actuators or kind of bendy, stretchy parts of it. And I think it's a great idea. It's been published in Advanced Materials. It's a work of Ava Bauer, Benjamin Tiebergen, and Esther Amstad. The paper is called 3D Printing of Double Network Granular Elastomers with Locally Varying Mechanical Properties. The thing that they do to get here is like, whoa, it's like super contrived, long-term kind of project. They're putting an oil and water emulsion, right, particles inside a precursor. That precursor is then absorbs elastomeric compounds, swells up. Then they make that, turn that into an ink. They put that ink into a bioprinter. The bioprinter prints it. Are you with me now? And then the other part of it is polymerized, creating these two different kind of intertwined structures. I think this is a really wonderful idea. Apart from this DNG concept and this particular iteration version of it, I think just this idea of making these intertwined networks is a very, very powerful one that other people should work on in different types of materials, trying to print materials in materials, if you will, in different kind of networks. I think this is a really wonderful idea. And I hope more people will do it. I think, soft robotics, we don't know if it'll work, but we can already see a lot of actuation, kind of end of arm tooling, kind of trying to get these finger-like properties where you want to grab something and be able to vary that, where this could be really super, super duper handy outside of just this really soft robotics area. So really hope more people will experiment with this. And the next thing is also wonderful. This is very kind of related. I think it's a very simple kind of a thing in a thing kind of thinking. So, and it's also kind of elastomeric as well. This is a wireless pressure monitoring system. So what they've done here, and this is beautiful. It's very, very elegant. So it's an origami-based pressure sensor array. So they've used a dual IDEX material extrusion printer, a really a kind of Vividino. It's called T-Rex 3.0. I'd never heard of it. Dual nozzle printer. It's about $1,800 or something like that. They've used Ninja Tech filaments. So two different Ninja Tech filaments. The Ninja Tech Cheetah, which is the 95A shore hardness, and then the Ninja Tech Eel, which is 90A shore hardness. They use these filaments. So I like this so much already because it's using a relatively affordable printer and it's using relatively filaments we can all get for part of this. Now, what they've done is they've made a kind of origami, a deformable kind of origami-based tube, a complex tube that you've probably seen a couple of times. People like to make these kind of tubes for kind of to demonstrate what you can do with silicone printing or with a TPU printing and stuff like that. And they've made this tube, and what they've done is quite, easily it says if you deform this tube, the tube will buckle, right? And the electrodes inside of it, the ribs that reinforce these tubes, these buckle as well. They deform. That changes the capacitance, and that turns this kind of dumb network of elastomers with, of course, some conductive elements into kind of a smart network of pressure sensors. And I like what they're doing with this as well. What they've done first is a pressure sensing kind of mat kind of application for if you would like try to get your foot scan and stuff, trying to see how you walk and all that kind of stuff. That's a great application. I think you could democratize this, make this really cheap. And they've also used kind of a more complex mat for more sports medicine type application. Imagine like an athlete, she's going to run, they're going to attach this to their ankle and see how she moves and all this kind of stuff and how it's changed or how it's under strain. I think it's wonderful because, if this works, if other people can copy it, it's going to be super cheap. And I can just really see this being used in orthopedics. I can really see this being used in orthotics, and I could really see this being used in sports medicine. And I think it's a really fantastic idea. And two great bits of elastomer news, essentially flexible stuff news, and one bit of news that maybe is going to lead to some fear mongering, or some silly legislation, or it's just a kind of a semi-fun news item for a lot of people who probably didn't know that you could make 3D printed keys. Anyway, my name is Joris Peels. This is 3D Printing News Unpeeled, brought to you by 3dprint.com. I hope you found this useful and you enjoyed your time with us today.